Ever had that feeling? Staring at, I don't know, a huge pile of books, maybe dense technical manuals, and just thinking, how on earth am I going to get all this into my head?
Oh, yeah, that information overload feeling.
Exactly. Especially when you're prepping for something really high stakes, like your ATPL theory exams. You know, that moment you realize you don't just need to know stuff about aerodynamics, lift coefficients, boundary layers.
Yeah.
You need to really understand it. And it just feels, well, a bit overwhelming. If that sounds like you, you're definitely not alone. So, welcome to the deep dive. This is where we take those complex topics, the very sources you're wrestling with, actually, and we boil them down into the essential stuff, the actionable knowledge. We're basically here to give you a shortcut to feeling genuinely clued up, hopefully spark a few aha moments, maybe even share a surprising fact or two.
And today, our mission is very specific. We're doing a custom deep dive just for you, our listener, who's right in the thick of it with those ATPL exams. We're going to pull apart one of the most fundamental but often misunderstood areas: aircraft stalling. We'll look at everything from the basic causes, why it happens, to all the different ways it can show up, sometimes quite subtly and crucially, the recovery procedures. And it's all going to be based firmly on the expert source material you've given us. The aim isn't just ticking boxes for the exam.
No.
It's about making sure you really grasp what's going on aerodynamically so you can fly more safely, more competently.
So what are we actually going to get into today? We'll unpack what a stall really is. Look at all the different things that change your stall speed. We'll explore the clever, sometimes sort of counterintuitive ways wings are designed to handle stalls. And of course, those vital warning systems, the prevention systems pilots absolutely rely on.
And we won't shy away from the trickier stuff either. We'll need to cover things like icing-induced stalls, the dynamics of spins, even high-speed buffet, which often gets confused with stalling. We want you to have a really solid, comprehensive picture.
Okay, let's dig into this then, because this is a topic every single pilot needs to master, isn't it? From flying a little Cessna right up to a massive jet. And it's also, I think, a great area for those moments where complex ideas suddenly just click. We're aiming for you to walk away from this feeling really prepared, really confident.
What I find fascinating is how concepts that seem simple on the surface, things like lift and angle of attack, they lead to such incredibly important, critical operational factors.
Yeah.
We'll connect the dots, link the theory to what actually happens when you're flying. Make sure this knowledge isn't just something you've memorized, but something you truly understand, almost intuitively.
Right. So to really get a grip on stall awareness, we need to strip it right back to basics and understand what a stall actually is. Forget the Hollywood drama. A stall is absolutely not about having insufficient airspeed. That's a really common and frankly dangerous misunderstanding. And for your ATPL exams, nailing this distinction is, well, it's vital.
Absolutely spot on. The core concept here, and maybe the single most important thing to take away, is that an airplane will always stall at the same angle of attack. Always. It's not a variable. It's a constant for a given wing design, under standard conditions.
Right.
We call it the critical angle of attack, or sometimes just the stalling angle. It genuinely doesn't matter what your airspeed indicator says, what the aircraft weighs, or what weird attitude you might be in. If you exceed that specific angle, the airflow over the wing, that smooth flow that generates lift, it just can't follow the curve of the upper surface anymore. It separates.
And when that separation happens, that's where the problems begin, and it can happen quite quickly. The consequences are immediate. Your coefficient of left CL, basically how efficiently your wing makes lift, it drops off rapidly.
Like losing grip.
Exactly, like a tire suddenly losing traction. And at the same time, your aerodynamic drag shoots up significantly. So this is why it's so crucial to drill this into your head. An airplane will always stall at the same angle of attack, the critical angle, regardless of airspeed or attitude. You can literally stall any aircraft at any speed if you pull back hard enough and exceed that angle.
Yeah.
For a typical wing, one without sweepback, that critical angle is around 16.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.